Here is a birth weight group. We have 4. How many cases in this data set? Remember that? It's 189, right? 189. So this is our data. So here we have 4 groups of the baby according to the weight. Okay, according to the birth weight. Okay. Every data I already give the description, so you can look at the description or the label of the variable. Okay. Here for the command we go to analyze and we go to the regression and ordinal. Okay, and then our dependent variable is birth weight group. Our factor here is smoke 1 because this is for categorical data, smoke 1, and the covariate is weight of mother. Okay, and then we need goodness of fit, we need parallel line. I will go to the option first. Option, we don't have to do anything now, make it as the default of the program. Output, what do you want to see from the output? Okay, maybe I will get this, it's right here, test of parallel line. It already have the goodness of fit already here. Okay, and we click continue. This is the output. For the location, we just need the main effect because now we have 2 variables, so we don't have to do anything in this box. And scale, don't have to do anything because we don't really need any scale model. Okay, bootstrap, we just don't have to do anything either. And then we just click OK. Let me want to see the. Okay, it already give you the descriptive statistic. Click OK. Okay, so this is a descriptive. How many groups? We have 4 groups. Okay, our total sample is 189. 59 go with less than 2,500. Okay, so we have 4 groups. And then this is our model. We also get the intercept only. This is mean the null model. No any predictor. It will start with the null model first. And the final, this means we have weight and we have smoke 1. We have 2 variables in model. So this is our final model because when we pick 2 variables. This is at -2 log likelihood. So you can see that when you have your final model, that when you have more variable, your -2 log likelihood is smaller. Smaller, that means it's greater, right? Because if it's smaller, because this value is -2 log likelihood, the smaller number, that means we have a greater number or bigger number of log likelihood. Because this is a minus sign. Okay, here. And the chi-square here, this is like the improvement test. Remember? The improvement test that we compare now model and the final model. So the improvement, we got 16.051 is come from these 2 numbers. We take the difference between these 2 numbers. And the value of the difference here is have a chi-square distribution with degree of freedom 2. And the p-value is less than 0.001. This means that your final model is significant, better than the null model. Okay? And this is the goodness of fit. Goodness of fit, we can look at Pearson or the deviant. Okay, I will look at the last one, the deviant. It is the p-value is 0.216. So is significant or not significant? Not significant. So this means our model fit well, right? when we test the model fit, we need the non-significant. And this is the R square. This is the R square. All of the R square here. I will explain later this one. But last time I already talked about Cock and Snell R square, right? We can pick one of them. Now, when we would like to report our paper, we just pick one. But mostly that we use Cock and Snell R square is equal to 0.081, which is equal about 8%. Okay, and this is our result for fitting the model here. Okay, this block, let me go to my slide, maybe better. Okay, I already talking about the output of the descriptive now. Okay, this is -2 of the log, the latitude from the output. Okay, this is the output. The pink part is the alpha or beta 0. How many groups we have? We have 4 groups, right? Our C we have 4 groups, so we have 3 alpha. For group 1, 2, the logic number 1, logic number 2, logic number 3. Okay, and we have 2 variables, weight and smoke. See, smoke is right here. The coefficient is 0.7 minus 0.72, and weight is 0.012. Let's see for the significant. This one for the ordinal, the logistic, the regression. Anyway, that I will not do the improvement test, but we can do the improvement test. But anyway, for this output, it's just have you that go directly to the wall test. You can just look at the wall test and look whether it's significant or not. Nah? So, but if when you analyze the data, if you prefer the improvement test, you can do the same pattern that you did in the binary logistic regression. Same pattern. You can do the improvement test. But this one, I would like you to go to the wall test. Okay, here for the wall test, for the p-value, for the weight, significant, right? 0.006 and smoke 0.009. So this means that weight is significant. Smoke status also significant. Okay, so whether murder and smoking are associated with birth weight. Okay, since the result of the wall test show us a significant result, which the p-value less than 0.05, 6 here is equal to the p-value. Okay. Now, how can we interpret it? How can we interpret it? Since our model, since the SPS fit the model like this form, okay, so how can we interpret? How can we calculate for the odd ratio? So the odd ratio is equal to exponential minus beta. This is a beta for weight. This and minus 0.72 is the beta for smooth one. So since the SPS will predict the probability of lower coding, let's say like that. So our odd ratio is equal to exponential of minus beta. Okay, and this odd ratio is odd for lower score to higher score, right? Go to this lower score to higher score. This is odd of lower score to higher score. Higher score is of birth weight for mother who smoke and mother who do not smoke. If I look at the smoke variable, okay. Now, before we interpret the odd ratio, we need to go to the coding scheme so we can interpret in the right way. Now, since we made an increasing sequence of coding for heavier weight baby, like this, heavier. The higher score, the heavier weight baby. Thus, we are choosing the heaviest baby as the reference outcome, right? So this means every logic model, we pick the heavier baby as the reference. All 3 logic models, all the time, right? that one you always with higher score because a higher score is a heavier weight. Okay, so let's go to interpret the odds ratio or calculate the odds ratio based on our outcome. Okay, odds ratio for smoking. What is the coefficient of the smoking if you look at the output? Minus 0.72. We have to take all, nah? Even plus sign or negative sign. Nah? So our beta is minus 0.72. So our odds ratio is exponential of minus beta. So exponential minus of beta, this is our beta. Okay, so it's gonna be the plus sign. So this is odds ratio equal to 2.05 because everything will be based on the SBS output. Okay, so it's gonna be 2.05. Okay, 2.05. So how can we interpret it? Because our outcome, not just binary outcome. So the interpretation, because now what is the reference group is the no, not smoking, right? So we can interpret that women who smoke during pregnancy have 2.05 times the odds of a lighter versus a heavier baby than women who do not smoke. This is the interpretation. Because odds ratio is greater than 1, and now we are predicting for the lighter baby. Okay. The rate, or we can interpret in terms that the risk of having lighter baby in pregnant women who smoke is about 2 times higher than those who do not smoke.